Good morning, good afternoon, good evening, wherever you guys find yourself in the world. My name is Brett Schechter, and I am the head of technical marketing. I'm going to do a little lead-in for Shailesh, and we're going to cover Kubernetes challenges today. We appreciate you joining us. We would very much like to make this as interactive as humanly possible. There is a question bar. Please familiarize yourself a little bit with the format and feel free to ask questions at any time. All right, let's get going. So most of you know Datera, but for those that don't, we were born in the cloud. The guys who founded this company are experts. They've worked for the giant hyperscalers. They've worked for some of the biggest and probably most significant data center companies. And back in 2012, 2013, they correctly surmised that although storage, with the advent of the all-flash vendors that had been born in 2010, was getting faster and maybe a little bit more reliable, it wasn't necessarily getting any easier to use. The shift into virtualization, which has now turned into a major shift into containers and additional automation, was really happening in earnest, and they wanted to create a product that would give you a cloud-esque experience, but with all of the enterprise capabilities that you would get from, let's say, one of those big three-letter vendors such as EMC. So enterprise software-defined storage lets you scale out very powerfully and across many different tiers and capabilities, but maintains that cloud-like user experience. We wanted to provide all of the then sort of nascent machine learning and artificial intelligence that, let's say, a DevOps person wants storage. They don't want to really worry about what's under the hood, and that was built into the product from its inception. It was really important for us to have very high-end performance, very low latency, very high IOPS, and all of the enterprise features that a Tier 1, even some Tier 0 customers would need and require. Probably why we're deployed in some of the biggest storage data centers in the world right now. High availability was a given, probably different than any other vendor at the time. We wanted to be able to rapidly deploy any new technology, for example, NVMe and Optane, any new media that was being introduced by the primary vendors, and our architecture nailed that as well. We had all experienced personally vendor lock-in. I ran big data centers for Rackspace back in that time, and we would get locked into a certain vendor. So we partnered with a number of the market leaders in hardware. We didn't want you to have to suffer from any vendor lock-in. I'll talk a little bit more about that. Also, the customers that are deploying Datera today, they're seeing real-world measurable TCO reductions, some even higher than 70%. All of this is why Datera is growing rapidly. The cloud is also growing rapidly, and I think at this point we all want to say the cloud has won. You've got a combination of private and public clouds. You can look at the numbers here from IDC. By 2025, the way you will likely be deployed is about 58% in private cloud, 42% in public cloud. You're going to need the ability to move those workloads between private, public, and on-premise in your own data centers. That's what Datera was designed to do, with tremendous agility, very fast. This is a Kubernetes discussion, and Shailesh is going to talk about some of that microservice velocity. Very simply, you don't have as many storage experts today as you may have had in the data center 15 years ago. It's probably a good thing. And probably most importantly, if you've ever purchased or used those big three-letter vendors, they're pretty expensive and not always the most cost-efficient. We wanted to make sure that we were. There's an interesting slide. Gartner just took a survey of 73 larger customers and asked them, how are you using containers today? It's very important that you choose a storage vendor that's going to be container friendly. Best if it's now. Why wait? Because as you can see from the slide, only 10% probably of you guys listening right now to me, are not doing anything with containers today. About 27% of you likely have containers deployed somewhere in your workflows, and we've got so many proof of concepts that are running at present at large companies. We know that this number is probably true. About 67% are testing and evaluating and ready to deploy containers. So you see serverless is actually making its first blip onto the map of what the primary abstraction layer might be for these customers in 2020. And that's interesting. We will certainly track that and probably talk to you about that a year from today. Pardon the redraw bugs. Thank you, Bright Talk, on this slide, but that's okay. We're here to help you overcome your persistent storage challenges. And I think the key one is, if you're a developer, you need persistent storage for your containers. The last thing in the world you want to do is figure out LUNs, IOPS, masking this, masking that, or anything that's under the hood. Datera's brilliance is the automation, and Shailesh, I don't want to steal his thunder, he's going to talk to that. The DevOps teams that you have in your companies, they're not data management people. They don't want to be. They shouldn't be. I mentioned automation and the autonomic nature and the awareness for both applications and microservices, and the way they have incredible velocity, both up and down, so both deploy and reuse. Also tremendous scale. Datera, for example, lets you start with 3 nodes and scale to 64 in a single cluster. And for customers that are doing that, that's multi-petabytes and millions of IOPS. You might need to grow that quickly. The apps are spun up and down fast, and there is no time for folks to say, I used to have to do it long ago, to sit there and manually provision, deprovision, reprovision, and try to figure out which way your workloads are going. That's all done under the covers with Datera. Our customers need enterprise storage features. They just don't want to have to pay that exorbitant, let's call it the 3-letter vendor tax and cost, the hassle, the fact that every once in a while, every 2 or 3 years, they either force you to migrate or make it so that you should migrate. So that complexity of traditional enterprise storage arrays, you don't get that with Datera, but you get all of the power. So deduplication, compression, replication, all the major security aspects and data durability, it's all built into the product. And we do it better in some cases than even the names that you all know. We want you to be able to run any app on anything from Tier 1 to Tier 4. And we support Optane and NVMe, so we actually have some guys who are running Tier 0 as well. We want you to be able to do it across any deployment mechanism you need. It could be bare metal, hypervisors, containers. It could be apps like Oracle 12, DB2, all the way through the ones that you guys are here to talk about, Mongo, Cassandra, Kafka, and others. So a lot of flexibility built into the platform. I'm going to go through this slide real quick. I think the key takeaway, this is Gartner telling you or recommending what type of storage you should purchase for containers. Probably the key point they make on this page, and it's somewhat unique to us, is that you want to make sure that you're integrated via CSI, not via customized in-tree plugins. And you also want to ensure that you've got distributed architecture, both for flexibility, scale out, and data durability. It's got to be DevOps friendly, and not everybody who says they support containers is necessarily DevOps friendly. Why would you buy Datera to support your stateful containers on Kubernetes? Well, there are arrays and NAS out there that are really confined to a single rack. Rack failures become an issue. We scale out both from a metro perspective as well as across racks and data centers, including stretch clusters. Very simple support within the product. Again, I mentioned we support bare metal containers and VMs, very DevOps friendly, and that means when you need a persistent volume, you want to be able to do that programmatically via REST APIs. Absolutely the widest array of storage classes and performance tiers, almost infinite. We've got some great literature that we might put into the description later to show you exactly how easy that is to do. You want to match each of these microservices to the perfect price performance and durability. Storage volume takes literally seconds to do that with Datera, and then Datera ensures that it stays that way as you make changes in the system. You want to isolate via multi-tenancy and RBAC. You want to isolate those microservices both for security and also performance and resource utilization. You don't want the noisy neighbor to intrude and take all the IOPS from other containers you might have running. Absolutely designed from the onset with multi-tenancy in mind. You want, I mentioned before, those enterprise features, dedupe, compression. They're all built into the Datera system. There's no additional cost for any of that, and very easy to support. We've had large customers tell us that the way they do storage management with Datera is revolutionary compared to what they've replaced, particularly at massive scale with the artificial intelligence we have built into it. That's about it for me. I'm going to turn it over to Shailesh now, and we're going to get into the meat of the discussion.
Thanks, Brett. Hello, everyone. So while knowing all the cool and salient features that Datera offers, fundamental question that comes in everybody's mind, what do they do with respect to an intelligent fabric like Kubernetes? Kubernetes was designed on the premise of simplicity, making your life easier with day-to-day operations you do in data center, how you provision your applications, how you introduce workload into the system, and how the resources are managed, and keeping these two worlds separate from each other, the application vendors from resource vendors, so that they both can grow independently without worrying about each other. And that's where we're going to focus our discussion today, that by using a technology like Datera, how we can make this experience even better and more naturally extended to the resources world than it used to be. So in Kubernetes, what are applications? So applications are injected into Kubernetes in the form of pods. Pods are nothing except a set of microservices running together. They co-hosted onto the same node. When there is a single microservice failure or something happens, all the services move together to another node. So the granularity of handling an operation in Kubernetes is a pod. Now, pod needs resources. Applications need resources, and they need compute resources, storage resources, network resources. Primarily from storage point of view, pod needs to introduce the storage requirement, and they do it in the form of PVCs, which is persistent volume claims. Persistent volume claims are something that people, application vendors would put in, okay, I want 100 GB, I want 3 replica, and some other labels, and this is how they will convey their storage requirement to Kubernetes. Once Kubernetes receives it, the idea in Kubernetes is you got your requirement, and now you need to match it to the storage resource that you have awareness of. So a persistent volume claim needs to be matched to a persistent volume in order for the pod to gain access to the storage resource. And for that point of view, the fundamental idea with Kubernetes is, as we talked about, like independence of two different worlds, the application vendors and resource vendors. That's where the resource vendors like Datera, they come into the system and make a promise to Kubernetes, okay, these are the resources I'm committing to Kubernetes for applications to use. So the idea here is when a requirement comes in, it will be using one of those resources, but those resources are published to Kubernetes Fabric before they can be used. Now, that's where the challenge comes in. Now, if I'm an application which is scaling super fast, I do not really want to sit back and wait for somebody to make the resources available and then tie up to them. It means I'm still tied to the resource existence before I can make a decision to scale. And I cannot really design an application in such a way because now I'm very worried about the resources, how they are coming in to the system. So what Kubernetes lets you do, Kubernetes came with something like a dynamic provisioning. And the whole point of dynamic provisioning is as and when the requirements come in, the resource vendor gets these requirements, and actually the resources are published at the same time when the requirement comes in. So basically, that keeps you off the hoop where you need to publish the resources before you can use them. Now, that brings in a real good challenge for the people because storage fabrics need to be thin provisioned. You cannot pre-provision the resources within the fabric and give other people the impression that, okay, resource requirement is coming in, I'm giving a slice out of it, and that's what a lot of vendors do. They basically pre-provision the resources with a certain personality, with a certain type, and as and when the requirements come in from Kubernetes, they basically make it available to the PVC, but actually defeats the purpose of dynamic provisioning. At Datera, what do? Like, we are truly dynamic. So the whole point is, when the requirement is coming in the form of PVC, at that time our CSI plugins and other things are making sure that we receive a request in the fabric and we carve out only the storage that is actually asked for. We are not pre-provisioning the resources here. So it's not something that we run out of resources and we have to remold our things to match other personality. We are absolutely making sure your system is not allocating any resource which is not asked for. A true, efficient way of allocating resources, better manageability. Moving forward, so as we are talking about on-demand provisioning, and as pods are introducing PVCs and they are getting matched, PVCs have a way to convey the requirement in such a way that it is more human. It's more simpler. That's what they were designed for. At Datera, we basically make sure that we have a lot of knobs and a lot of policies and a lot of personalities built in. Our system is written and developed on the premise of flexibility that no two workloads going to be similar. So when an environment like Kubernetes, which has plethora of applications, each application has a different personality for resources that it needs from the fabric underneath, they offer storage classes. So in Kubernetes, you can create a storage class, which basically defines the personality of the storage that you need. And that storage class poses the requirement like PVC into the system. Now, storage classes are the way of giving you consistency, but at the same time, they also give you a wide spectrum of storage profiles that you can put into the system. And that's how an application differentiates from other applications, that how they want the resources to be used. Now, that's what Datera does the best, because in our system, we can take as many storage classes as you want. Be it for your DB, you may have a different requirement. For your bare metal, you have a different requirement. For your general usage, you may have a different requirement. So if you have something conveyed in the form of very simplified fashion, like I want a platinum, I want a gold, I want a silver class of storage resources, I want a bronze classes of storage resources. At Datera, you can match them to a performance tier. And that performance tier is nothing except you are tying up a bunch of services that you need from the storage fabric and naming them, labeling them, and exposing them back into Kubernetes. So Kubernetes application vendor can actually point to that referenced integrated set of services without actually worrying about what those services are. So if I'm a Kubernetes application vendor, I can just simply go and say, okay, I want platinum class of service. And by doing that, I automatically get mapped to a set of integrated services like compression, dedupe, or more replication or default data protection using snapshot policies automatically without me worrying about it. Great power in abstraction. So the fundamental idea is pods are actually defining the kind of personality they want to use from storage resource point of view. They define that personality using storage classes in Kubernetes. They match these storage classes in Kubernetes to one of the performance tier in Datera. And Datera takes this performance tier and matches it with the set of services and the kind of media it needs to expose up. and that's how we pin the storage back to the application. So application decides what it wants. Under the hood, admins can make sure that this application gets the guaranteed access to the resources that it has asked without exposing application user or a developer to worry about, okay, how these resources will eventually be carved out. So we are actually fulfilling the promise of keeping these two worlds absolutely independent of each other. So as I talked about, since we offer a huge range of storage classes, and that's what a typical Kubernetes arrangement would be. A big spectrum of applications going to be running in. They'll be working in a fashion that they have different piece of requirements at every application level. So you can actually pick a storage class, as we talked about. You can choose a performance tier, and you can pick any type of storage resources. So Datera Fabric works on heterogeneous media. So we do support different types of nodes to be put together into a single fabric. The fundamental idea is whatever node you put in to Datera Fabric, we understand about it, and we create a personality around those things. So as and when the requirements are coming in from application space, and when these requirements are conveyed to Datera, we are able to match what tier that you should be exposed to and what tier of storage we should connect to the application so that application can fulfill its job without losing its effectiveness. If any of those tiers needs a maintenance or any of the nodes come in and go out, that is absolutely under the hood. So we make sure that these tiers are not disturbed just because you are having a temporary outage in the system or anything, and application vendors remain immune to all these changes. And that's the promise of an enterprise-grade storage, because storage downtime is absolutely no. And a scale-out environment like Kubernetes, where requirement on the resources is more dynamic than ever, it is very, very important for a storage vendor to make sure that you give flexibility, but at the same time you give resilience to all these failures so that applications are not suffering because anything going wrong in the fabric. But by offering the widest range of storage classes, we are absolutely making sure that multiple of these applications, whether it be traditional application or modern applications, which are absolutely based on microservices and other things, can stay together. You do not really need to create another silo in your system just to make sure your traditional applications are running differently than applications running in Kubernetes. And that's where the storage fabric comes into the picture, because you are offering compression, you're offering dedupe, you're offering all kind of enterprise-grade great features, but you are also making sure that you are offering a flexibility to the applications that how they can literally use the system underneath. And since Datera is built on the principles of REST APIs, any interaction that you do from Kubernetes or via Datera UI or via API or any other ecosystem, the communication mechanism still remains as is. So it means it gives you more flexibility to mature your workloads in any other environment and bring them to Kubernetes, because we can literally take in your same manifest and bring it into the system and not worry about it, because we have all the operations exposed using REST API. Tremendous way developers can use it using programmability and kind of API provisioning way. So this is the overall view how the dynamic provisioning happens in Datera, and I'm going to spend like quick minute on this. So Kubernetes, as we talked about, has a lot of constructs like stateful sets, replica sets for scaling the applications up and down. So if you really take a picture here, so a stateful set introduces a pod into the system, but stateful set conveys the requirement of the storage resources using volume claim template. And what we have done in the template, we are pointing to a storage class. So the idea here is when this stateful set introduces a pod, before that it will introduce a PVC. The PVC will be based on the storage class that you mentioned. If you take a look in the left bottom of this slide, the storage class does talk about what is your provisioner. It means how the storage is going to be coming in and what the template it will use. So if you pay a little attention, what it is doing is storage class is conveying the requirement that I want a dynamic volume to be created against this PVC, and I want Datera to be used as a provisioner, and I want to pass a parameter as template goal. That's it. Application vendor is not doing anything beyond that. And now what would happen underneath, when the PVC is created, Datera CSI plugin receives a request that it needs to carve out a volume, and it receives a request says, okay, this volume needs to be referenced, volume needs to be provisioned using the template gold. And if you see on the right side, the template gold actually conveys, okay, I want a 3-way replica, and I have an IOPS limit, hypothetically take any number, it could be larger number too, but I'm creating a application instance or a volume using this template, and now publishing it back into Kubernetes Fabric by attaching it to a PV. Now, once this PV is created, it automatically gets claimed by this PVC. That's what Kubernetes does it for you. And by doing that, the storage is actually pinned to the pod that just got created. So if you see the pod 1 gets access to app instance production 1 via Datera CSI, but application vendor was not exposed to any complexity or any detail underneath the storage fabric. They don't really need to know what are the replica factors are, what are the IOPS numbers are, what protection schedule do you want. By just defining a referenceable word as template equal to gold, they immediately got access to. And this gives a lot of power, because now a vendor can decide, okay, hey, what your goal should be. So you can literally go to the Datera and say, okay, my goal is no longer 5,000 IOPS limit and all those things. I want my goal to be terminating on the super high performance node, or I want a protection schedule like this, or I want to put a deduper compression and everything on top of it. It immediately becomes available to your pod. So application vendors are not doing anything. But at the same time, if application vendor wants some flexibility, say, okay, hey, I designed my application using gold, but I don't like it. I want to tone down my performance requirements my application doesn't really need, and I just want to move to a silver. So for me, the interpretation as an application vendor is, I want to go to a lower performing tier, and which is silver for me. I do not really care what the silver is. I just want a little lower performance because I figured out my application doesn't need that much. And guess what? At Datera, you can just define a template as silver, and that will make sure that your resources are a little toned down. Instead of terminating onto an NVMe flash, you may be going to a normal SSD-based node, or you may be going to a hybrid media. So it gives flexibility in both the worlds, where application vendors do not really need to worry about what the storage resources are there underneath. And similarly, the storage vendor, like Datera or an admin who is working on the storage resources, does not really need to know how the application is going to be using it. So they can basically mix and match, and that gives a lot of power, a lot of flexibility to the people. So with containers, there come greater problems, because Kubernetes was designed to scale. And when anything is designed for scale, people can actually shoot themselves in the foot without even knowing. You want to scale a stateful set, and suddenly you realize, oops, instead of increasing the replica from 10 to 100, I accidentally did it to 1,000. Now, suddenly, before even you notice, your system has got 900 additional instances of the same application running in. It may hog the entire system, make your critical application starve if your fabric is not intelligent. So Kubernetes solves this noisy neighborhood problem by letting you isolate your pods and resource claims under a namespace. But what about the fabric underneath? You are getting resources from a storage vendor. You're not getting resources from Kubernetes. So when these things are extended, when these namespaces, they need a true fabric which can actually extend this namespace into more meaningful construct. In Datera, we are built on tenancy. We are built on multi-tenancy. This is how the system is built from the ground. We let you control where your workloads will be provisioned. So we can control all the Kubernetes requirements originating from a single namespace are terminating onto one Datera tenant. And on that Datera tenant, you can put the throttling numbers. You can put a quota restrictions. You can say, I do not want this tenant to ever exceed beyond 200,000 IOPS. I do not want this tenant to ever create resources which are exceeding, let's say, 5 terabytes. So even if a requirement gets originated in Kubernetes, which is actually asking for way more resources than it should have, you are secure. You have that confidence that irrespective if there is a rogue application that is scaling in Kubernetes world, my environment is protected, because Datera will make sure that resources are not getting extended beyond what the limits I have set them for. You want to tune down. Let's say an application has scaled up for thousands of instances genuinely, and you want applications to be like that. But suddenly you realize, okay, this entire application doesn't need to have that many resources, or I need to inject more resources for this application. Since you are using a Datera template underneath, you can actually go to the Datera template and tune it. And you can specify, okay, I want to put a cap against every volume. So I can just simply say and go, okay, instead of everybody doing uncapped IOs, I want to limit every instance to 5,000 IOPS. Now, by doing that, all the instances that were created earlier using the template automatically receives a throttling. So your entire Kubernetes environment where all those 1,000 instances were running in automatically get throttled. Now, that's the power. That's the power user would need. That's the power admins would need to just make sure their system scales up and scales down. You're having a lot of applications running in Kubernetes environment, and you have Datera storage running with, let's say, 3 nodes or 6 node cluster, and suddenly you realize, okay, hey, I think I'm running out of resources. I need to add more resources to the system. In Datera, you can seamlessly come and add another node based on how you want it. You can add multiple nodes as you want it. Datera Fabric is self-adjusting, self-manageable. So it can automatically start spreading and make more resources available to your Kubernetes environment. And you can scale up without losing your SLAs. So we give power to both the worlds. And we make sure that your applications are not suffering because resources are underneath are suffering because there's a maintenance going on. Okay, we make sure that your resource pool using the storage technology are able to extend without worrying about how the application is going to be using them or not. So it's a lot of power. It's a lot of restrictions that Kubernetes poses, because once Kubernetes resources are configured, even let's say, for an example, you create a PVC out of a storage class, and you just want to change the personality of your PVC, saying, okay, hey, I made a mistake. I need to go and change my storage class. The PVCs which are already created using storage class not going to receive the change if you make the change to a storage class. But since you terminated your storage onto Datera, you have flexibility. Now, the template that you have used to tie your storage with the storage class, that template you can go and make a change. And by making that change, whole environment in Kubernetes automatically receives this change. We support secrets. We have RBAC built in at every layer in the Terra system. So you can control who accesses your tenants, who accesses your storage resources. So not an unwanted user can come in and hog your entire system. You basically control how the interaction would be. And that's where you have a separation of roles. People can decide, okay, storage vendors, a storage administrator has a different role. He's just managing the resources and everything. An application developer can access to the resources via certain constructs that you publish, like storage classes and everything. And this is how you can make sure that none of these two guys are interfering into each other's world by making unsolicited requests that they should not be.
Shailesh, that was amazing. I don't see any questions in the chat, but I've got a question for you before I get to this slide. So let's assume that that request wasn't an error. You needed to go from 10 to 1,000 containers, and they were very demanding containers. As you add those Optane or NVMe or high-performance flash nodes to Datera, how long does it take before the system responds to this new request? So maybe you've set the limits properly, but the system itself is now getting a little starved for resources. Is that a day? Is that a week?
So it's a great question, Brett. And as I mentioned earlier, our system is built on understanding the principles that resources are dynamic. They'll keep coming in and keep going out. And as we understood earlier, at Datera, when a new node is added, we immediately start understanding, okay, what type of node it is, what kind of personality it has got, what kind of IOPS does it bring into the system. And we label that node for a tier. We know, okay, what kind of tier this node belongs to. And by doing that, very quickly, we understand, okay, hey, which capacity in what personality we have improved. So if there are any applications which require resources from that high-performing tier, if let's say you have added a very high-performing tier like an NVMe Flash node, and you were only having SSDs earlier, by doing that, we can immediately start moving the workloads to that tier, which are actually starving for performance. At Datera, we do support multiple adherence policies, what we call them as placement policies. and you can define how rigorous you want to be with their placement. So you can actually have something like a strict placement mode or a best effort placement mode. So if your application absolutely need to have a certain level of performance, you can go for a strict placement mode. So if your system do not have that kind of performance, it'll basically tell you upfront, okay, I cannot go in provision. But if you do best effort, it'll actually place your workload onto a tier which it finds most available at that time. And once a high performing tier comes in, it'll start moving your workload. So it's not a week, it's not a day, it's immediate.
Outstanding. Good to hear. And actually, that's a good lead-in. By the way, please keep the questions coming. It's a good lead-in to this slide. There are literally 4 or 5, I'm going to show you 4 here, different ways that you could deploy storage with Kubernetes and containers in general. You've got direct attached storage, that dinosaur from the past, a lot of performance, not a lot of flexibility. You've got your traditional monolithic arrays. Hyperconverged is often mentioned, and for some, maybe moderate performance, that might be a solution. Datera and software-defined storage, however, and I'm going to draw your eye on this slide to only a couple, just in the interest of time. The most important thing is to have a separation and the ability to tune and grow and expand storage separately. You want best of breed, and you get that with Datera. As Shailesh just mentioned, you can add Optane, NVMe nodes, and do it effortlessly and heterogeneously. You can mix and match them. You can't necessarily do that with most of the HCI solutions that you'll find out there. Also, the ability to, let's say, and we've got a number of customers that are doing this, shift reasonably easily from L2 to L3 networks, throw in stretch clusters. These are all enterprise-grade capabilities. You'll find them with Datera. You won't find them, at least not effortlessly, with any of the other solutions. We've got very tight integration with Amazon and S3, and that's only going to improve in the future. So we think we have a very unique solution. And just to recap, why Datera for stateful containers? I want you to take away the way we manage storage, as Shailesh detailed, works at massive scale. It uses and was built from the ground up to use artificial intelligence back when nobody else was thinking about using it. We support everything that you might use or need in the data center, including bare metal. So we're one of the few solutions where you can run massive containers deployments at scale and also be running some bare metal servers for maybe some of your legacy apps that you might need to. Very DevOps friendly, very simple and exposed REST APIs, simple to scale along with Kubernetes scale. Impressive, if not infinite, number of storage classes. Your microservices are not going to need expensive pre-provisioned storage that may or may not stay in tune, so you can find the perfect storage volume for each of those microservices. Tremendous multi-tenancy, and built again from day one with all that multi-tenancy. And we also have enterprise storage features without the enterprise storage complexity. So things like dedupe compression and any kind of security that you might need. Very simple to turn on and off, and even, as Shailesh indicated, make changes in the future if necessary. So that's it from us. Actually, I want to point you guys, we have 3 attachments and links within this webinar. If you're listening to it on demand, please feel free to click on them. By all means, I thank you for being here, but please take a look at the website. Shailesh, hot off the presses, did an outstanding Kubernetes Lightboard video. A lot of these concepts in there, but in much greater detail. So highly recommend that you take a view of that. If you want more information, and more importantly, if you want a proof of concept and try this out in your own data center, then by all means, please use the links that you see here. So I'm going to leave it open for about another 30 seconds, 10, 15, 30 seconds, see if there's any other questions. Shailesh, is there anything that you don't think you covered?
No, I think we did. Just for a closing thought, one thing whenever people deal with Kubernetes, look, Kubernetes is an open source tool. A lot of community is working on this, and the pace of development at any open source framework is basically driven by the community, and that's where people sometimes it happens that you want to use a feature and the feature is not there in the tool. By using abstraction, using our templates at Datera and all those things, it becomes way more easier for people to forward provision things without even Kubernetes supporting it, like resize and other things. Just a prime example, your workloads will change, your system will change. You got to have a fabric in the system which can actually let you use some of the things that even are not exposed as primary options in Kubernetes. And that's where Datera can come in. And not on the expense if Kubernetes exposes that option tomorrow, we are ready to use it because we are REST driven. We exactly use the same manifest as you have been using earlier. So we are future proof in that context if you deploy us along with Kubernetes. And that's what I see, like Datera is doing pretty well, and we are prime position for making sure that workloads can be used as simply as you mentioned, but at the same time not at the expense of losing the flexibility and effectiveness.
Right, that's great. We really appreciate your time today. Oh, actually, a question just came in. Do we work with Microsoft Azure? We don't at present, but we certainly are evaluating. So that may change in the future. Any other questions? If not, I thank you all so much for joining. This will be available on demand, and I look forward to seeing everybody back on Bright Talk and elsewhere in the future. Thank you again.